Seal-tight, also known as liquid-tight flexible metal conduit, is designed to safeguard electrical wires against environmental factors like moisture and physical damage. However, its construction and material composition are not suitable for high-voltage applications, such as a 220-volt circuit for a hot tub. Attempting to use seal-tight in such a scenario presents a significant safety hazard, increasing the risk of electrical shock or fire. For a 220-volt hot tub circuit, it is essential to use a conduit system that is specifically rated for the voltage and current requirements of the circuit. Two common and acceptable options are electrical metallic tubing and rigid metal conduit. Electrical metallic tubing is a lightweight, non-flexible metallic conduit that is typically made of galvanized steel or aluminum. It is suitable for use in dry locations and can be installed indoors or outdoors. Electrical metallic tubing provides excellent mechanical protection for electrical wires and can be easily bent and cut to fit the specific needs of an installation. It is also relatively inexpensive compared to other types of conduit. Rigid metal conduit is a heavier, more robust metallic conduit that is typically made of galvanized steel or aluminum. It is suitable for use in both dry and wet locations and can be installed indoors or outdoors. Rigid metal conduit provides superior mechanical protection for electrical wires and is often used in applications where the conduit is likely to be exposed to physical damage. It is also more expensive than electrical metallic tubing. When selecting a conduit for a 220-volt hot tub circuit, it is essential to consider the following factors. Firstly, the voltage and current requirements of the circuit. The conduit must be rated for the voltage and current of the circuit to prevent overheating and potential electrical hazards. Secondly, the location of the conduit. The conduit must be suitable for the environment in which it will be installed, such as dry or wet locations. Thirdly, the potential for physical damage. The conduit must be able to withstand the potential for physical damage, such as impacts or abrasion. Fourthly, the applicable electrical codes and standards. The conduit must comply with all applicable electrical codes and standards, such as the National Electrical Code, or NEC. The National Electrical Code is a widely adopted standard for safe electrical installations. It specifies the requirements for electrical wiring, overcurrent protection, grounding, and other aspects of electrical systems. Article 344 of the National Electrical Code covers the requirements for rigid metal conduit. Article 358 covers electrical metallic tubing. These articles provide detailed information on the permitted uses, installation methods, and support requirements for each type of conduit. In addition to selecting the appropriate type of conduit, it is also important to properly install the conduit system. This includes ensuring that the conduit is properly supported, grounded, and connected to the electrical panel. Proper grounding is essential for preventing electrical shock hazards. The grounding system must be designed to provide a low impedance path for fault currents to return to the source, tripping the circuit breaker and energizing the circuit. Incorrect grounding can result in dangerous voltage on metal parts of the electrical system, increasing the risk of electrical shock. When installing a conduit system, it is important to use the appropriate fittings and connectors. These fittings and connectors must be listed for use with the specific type of conduit being used and must be properly installed to ensure a watertight and secure connection. The use of incorrect fittings or connectors can compromise the integrity of the conduit system and increase the risk of electrical hazards. It is also important to properly size the conductors that are installed in the conduit. The conductors must be sized to carry the maximum current that the circuit is expected to draw. The National Electrical Code provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. Using conductors that are too small can result in overheating and potential fire hazards. In the specific scenario described, where the AWG8 wire is running through the basement on the foundation edge from the main panel to a sub-panel for a hot tub, the use of electrical metallic tubing or rigid metal conduit is recommended. The conduit should be securely fastened to the foundation while using appropriate mounting hardware. The conduit should also be properly grounded to ensure electrical safety. It is important to note that electrical work can be dangerous and should only be performed by qualified and licensed electricians. If you are not comfortable working with electricity, it is best to hire a professional to perform the work for you. When working with electricity, it is essential to follow all safety precautions. This includes wearing appropriate personal protective equipment such as safety glasses and gloves. It also includes de-energizing the circuit before working on it. De-energizing the circuit can be accomplished by turning off the circuit breaker that supplies power to the circuit. Before working on any electrical equipment, it is essential to verify that the circuit is de-energized using a voltage tester. A voltage tester can be used to check for the presence of voltage in the wires and equipment. If voltage is present, the circuit is not de-energized and it is not safe to work on it. In addition to de-energizing the circuit, it is also important to lock out and tag out the circuit breaker. This prevents someone from accidentally turning this circuit breaker back on while you are working on the circuit. Lockout-tagout procedures involve placing a lock and tag on the circuit breaker to indicate that the circuit is being worked on and should not be energized. The tag should include the name of the person who is working on the circuit and the date and time that the circuit was de-energized. Electrical safety is paramount when working with electrical systems. By following all safety precautions and using the appropriate materials and installation methods, you can minimize the risk of electrical shock and fire hazards. Remember to consult with a qualified electrician if you have any questions or concerns about electrical work. The information provided in this narration is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Moreover, understanding the specific types of conduits and their applications is crucial. Firstly, consider electrical non-metallic tubing. Electrical non-metallic tubing, or ENT, is a flexible, corrugated plastic tubing used for electrical wiring in walls, floors, and ceilings. It is lightweight, easy to install, and resistant to moisture and corrosion. ENT is commonly used in residential and commercial buildings for branch circuits and lighting. Secondly, intermediate metal conduit. Intermediate metal conduit, or IMC, is a steel tubing similar to rigid metal conduit but with a thinner wall. It is lighter and easier to bend than rigid metal conduit, making it suitable for applications where weight and flexibility are important. IMC provides good mechanical protection for electrical wiring and is often used in industrial and commercial settings. Thirdly, liquid-tight flexible non-metallic conduit. Liquid-tight flexible non-metallic conduit, or LFNC, is a flexible, non-metallic conduit used to protect electrical wiring in wet or corrosive environments. It is resistant to oil, chemicals, and sunlight, making it suitable for outdoor and industrial applications. LFNC is often used to connect motors, pumps, and other equipment in harsh environments. Fourthly, flexible metal conduit. Flexible metal conduit, or FMC, is a flexible, metallic conduit used to protect electrical wiring in dry locations. It is often used to connect lighting fixtures, appliances, and other equipment where flexibility is needed. FMC is relatively easy to install and can be bent to fit around obstacles. Fifthly, aluminum conduit. Aluminum conduit is a lightweight, corrosion-resistant conduit used in electrical wiring systems. It is often used in coastal areas or other environments where corrosion is a concern. Aluminum conduit is available in both rigid and flexible forms and can be used for a variety of applications. Choosing the right conduit for a specific application depends on several factors, including the environment, the type of wiring, the required level of protection, and the applicable electrical codes. Consulting with a qualified electrician is recommended to ensure that the correct conduit is selected and installed properly. When installing any type of conduit, it is important to follow the manufacturer's instructions and all applicable electrical codes. This includes using the correct fittings, supports, and grounding methods. Improper installation can compromise the integrity of the conduit system and create safety hazards. Additionally, understanding the importance of grounding and bonding in electrical systems is paramount. Grounding and bonding are essential safety measures that help to protect people and equipment from electrical shock and fire hazards. Grounding provides a path for fault currents to flow back to the source, tripping the circuit breaker and energizing the circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault currents. The National Electrical Code specifies the requirements for grounding and bonding in electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. Improper grounding and bonding can create dangerous voltage on metal parts of the electrical system, increasing the risk of electrical shock. Moreover, considering the impact of ambient temperature on conductor ampacity is critical for ensuring safe and reliable electrical installations. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor is affected by the ambient temperature, which is the temperature of the air surrounding the conductor. The National Electrical Code provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. These tables are based on the assumption that the ambient temperature is 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductor must be reduced. This is because higher temperatures increase the resistance of the conductor, which reduces its ability to carry current safely. The National Electrical Code provides correction factors that can be used to adjust the ampacity of a conductor for different ambient temperatures. It is important to use these correction factors to ensure that conductors are not overloaded, which can lead to overheating and potential fire hazards. Also, understanding the requirements for overcurrent protection in electrical systems is crucial for safety. Overcurrent protection is a safety measure that protects electrical circuits and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. The National Electrical Code specifies the requirements for overcurrent protection in electrical systems. These requirements are designed to ensure that electrical circuits and equipment are protected from damage caused by overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. Short circuits occur when there is a low resistance path between two conductors, such as when a wire comes into contact with a metal object. Overcurrent protection devices must be sized to protect the conductors in the circuit. The size of the overcurrent protection device is determined by the ampacity of the conductors. The National Electrical Code provides tables that specify the allowable ampacities of conductors based on their size and insulation type. Additionally, learning about the importance of using properly rated electrical equipment is necessary to keep safe. Electrical equipment, such as switches, receptacles, and lighting fixtures, must be rated for the voltage and current that they are expected to carry. Using electrical equipment that is not properly rated can lead to overheating, electrical shock, and fire hazards. The National Electrical Code requires that all electrical equipment be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listing by a recognized testing laboratory indicates that the equipment has been tested and found to be safe for its intended use. When selecting electrical equipment, it is important to choose equipment that is rated for the voltage and current of the circuit. It is also important to choose equipment that is listed by a recognized testing laboratory. Using properly rated electrical equipment is essential for ensuring the safety and reliability of electrical systems. Moreover, complying with all applicable electrical codes and standards is very important to adhere to. The electrical codes and standards are designed to ensure the safety and reliability of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. The National Electrical Code is the most widely adopted electrical code in the United States. The National Electrical Code is updated every 3 years to reflect changes in technology and safety practices. Complying with all applicable electrical codes and standards is essential for ensuring the safety and reliability of electrical systems. Failure to comply with these codes and standards can lead to electrical shock, fire hazards, and other safety risks. It is important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable electrical codes and standards. Finally, always remember the significance of hiring a qualified electrician. Electrical work can be dangerous and should only be performed by qualified and licensed electricians. Qualified electricians have the training, experience, and knowledge to perform electrical work safely and in accordance with applicable electrical codes and standards. Hiring a qualified electrician can help to ensure that electrical work is performed correctly and safely, minimizing the risk of electrical shock, fire hazards, and other safety risks. When hiring an electrician, it is important to check their credentials and references. Make sure that the electrician is licensed and insured. You can also ask for references from previous customers. Hiring a qualified electrician is an investment in the safety and reliability of your electrical system.